Today we're going to start our study of quadrilaterals. So we're going to fill in a couple of properties for quadrilaterals. A quadrilateral is a four-sided figure. Four sides. A quadrilateral. In a quadrilateral, the sum of the interior angles. So angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360 degrees. And the third is the sum of the exterior angles is 360 degrees. So what that means is if I were to extend each segment that makes up this quadrilateral, just going to bring these in here, and I was to extend the segments like that, then angle 5 plus angle 6 plus angle 7 plus angle 8 would also add up to 360 degrees. So the sum of the interior angles is 360 degrees. The sum of the exterior angles is 360 degrees. Please make sure you fill that in. Hit pause if you need to. Okay, turn to page 4. We're still going to be talking about quadrilaterals, but there are what we call special quadrilaterals, one of which is called the parallelogram. So we're going to talk about the parallelogram. A parallelogram is a quadrilateral with opposite sides parallel. So if you look at the picture here, you'll see that they have the markings here that represent parallel sides. So the left and the right are parallel to each other, the top and the bottom are parallel to each other, and so we have these 5 properties of parallelograms. The first being 2 pairs of opposite sides are parallel, and the markings are shown there. The second is that there are 2 pairs of opposite sides that are congruent. So if I want to show that things are congruent, segments are congruent, I'll make it 1 marking on the top and bottom, and I'll make 2 for the left and the right. Okay, so opposite sides are congruent. Third, 2 pairs of opposite angles are congruent. Okay, so you have 1 pair would be the top left and bottom right, so opposite angles. And the second pair would be top right, bottom left. Opposite angles are congruent. Fourth, consecutive angles are supplementary. So if you notice, you have 1 angle here and another here. They are not congruent. If they're not congruent to each other, they're going to be supplementary. So consecutive means one after the other. So if I start here and go to the next angle, those 2 are supplementary. If I start at this angle here and go to the next, those 2 are supplementary. So if they are not congruent, then they are supplementary. Lastly, the diagonals bisect each other. Okay, so what that means is, I'm going to draw this into this one. If I take a line segment and extend it from the top left to the bottom right, and then I take another segment and I extend it from the bottom left to the top right, I'm going to have drawn in diagonals. And what this is saying, this property, is that bisect means cut in half. So I'm going to have this segment and this segment congruent, but I also have these 2 segments congruent to each other. So the diagonals bisect each other, give you 2 pairs of congruent segments. Okay, so these properties are properties that you need to know, you need to memorize. We will have a quiz tomorrow on them, and you have to be able to state the properties of the parallelogram, in addition to the 3 properties of the quadrilateral. Okay, so not only do we have to look at these properties and memorize them, but we have to know how to apply them. So let's look at practice problem number 1. We have given a parallelogram RSTW with RS, okay, let's stop there for a minute and just draw in your parallelogram. So draw the picture, and we're going to label it. So we're going to bring the letters around. So R, then S, then T, then W. You can go clockwise, you can go counterclockwise, it doesn't matter. I could go this way, RSTW, as long as you go in order. Okay, so I always go top left and move around, so that's the way I'm going to keep it. Okay, so the next thing we need to do is look at the information they're giving us. Well, they're giving us that RS is 2x plus 7. I have ST as 3y minus 5. I have TW is 25. And WR is 16. WR is 16. Okay, now I'm just going to highlight these sides a little bit. So RS, this is RS. This is TW. ST is here, sorry. And WR is over here. Okay, why did I do that? Because I want you to label the given information correctly. So we're going to put RS as 2x plus 7. And we have TW as 25. And we have, I don't know if it's going to show up, we're going to have ST as 3y minus 5, and we have WR as 16. Okay, next step. You're going to look at what they gave you. They gave you sides. Now look at your properties of your parallelograms. You're looking for something that says sides. Well, here's one that says sides, and here's one that says sides. We have the sides are parallel, and we have the sides are congruent. Which of these is going to help us out with this problem? Because they're talking about the lengths of the sides, not the slopes of the sides. So I think we should use the fact that there are two pairs of opposite sides congruent, which means that RS, the length of RS, equals the length of TW. So we can fill in 2x plus 7 is equal to 25. And we solve and we get, well, let's see what we get. We get 2x equals, and that's going to be an 18. If we divide by 2 on both sides, we get x equals 9. Okay, so they're actually looking for the values of x and y, so we have x equals 9. And now we would do the same exact thing for RW and ST. So RW and ST are opposite sides. Opposite sides are congruent, so the lengths are equal in measure. So we have RW as 16, and we have ST as 3y minus 5. We're just substituting in what they have given us for those lengths. I'm going to solve for y, and I get 21 equals 3y. I can divide by 3 on both sides, and I get y equals 7. So x equals 9, y equals 7, and we are done. We found the values of x and y. Okay, we're going to move on to number 2. Given parallelogram RSTW, so let's just stop and draw it. So you're going to draw your parallelogram and you're going to label it RSTW. Such that diagonals SW and RT intersect, that should be over there, intersect at Z. Okay, so we're going to draw diagonals in. Diagonals go from top left to bottom right, and bottom left to top right. And they intersect at Z, so draw a little Z in there. Okay, if WZ is 4x minus 3, so let's label 4x minus 3, and ZS is 13, ZS is 13, RZ is 17, RZ 17, and ZT is 7y plus 3. Solve for the values x and y. So we have little lines here, so we can put x equals and y equals. Okay, so let's do x first. So 4x minus 3 is on this here. diagonals. So let's think about properties. Let's go back and look at the properties and see which one talked about diagonals. I have to go back a couple of pages. Here we go. Diagonals bisect each other. That means the diagonals are cut in half. That also means that this here, oops, I got my Z out of there. This WZ is congruent to ZS. Diagonals bisect or cut each other in half. Therefore, we can write that WZ is equal to ZS. Okay, so once we have that written, we can substitute in 4x minus 3 is equal to 13. Now we can solve 4x, and you get 16 there, and we're going to divide by 4 on both sides, and we get x equals 4. Okay, so now we're going to do the same thing for y. I have a segment with 7y plus 3 here. Well, if these diagonals bisect each other, then zt is congruent to rz. So I can write zt, if they're congruent, they're equal in length. So zt is equal to rz, which means I can substitute in 7y plus 3 is equal to 17. And now I can solve for y. So go ahead and do that. Okay, and you should have gotten y equals 2. So if you didn't, just kind of look over here and see where you went wrong. Alright, so we're going to fill our answers in here. We have an x equals 4 and a y equals 2. Okay, ready to go on to the next one. Okay, number 4, parallelogram ABCD. Let's label it ABCD. And we have the ratio of the measure of angle A to the measure of angle B is 2 to 7. Okay, well that's not saying that this is 2 degrees and this is 7 degrees. So if I write it in, it's easier to see that that just can't be what they're talking about. It's the ratio, so it's going to be 2x and 7x. Okay, we have angles again. So you go to your properties and look at your angle properties. There's only 2 of them. So are these opposite angles or consecutive angles? Well, they're consecutive angles. Consecutive angles, or the sum of consecutive angles, are 180. They're supplementary. So we're going to say that angle A plus angle B is equal to 180 degrees, and and that's the measure. And by substitution, I can say that 2x plus 7x equals 180. That means that I have 9x equals 180. You're going to solve for x, and I'm going to have x equals 20. Now, the question is asking, find the measure of angle C. So we're not done yet. X is not our answer in this case. Well, here's the relationship I know. I know that these 2 are supplementary, and these 2 are congruent. So opposite angles are congruent. So if this guy here, A is 2x, 2 times, instead of x, we can substitute in 20 now, is 40. So this angle A is 40, which means angle C is 40, using the property opposite angles are congruent in a parallelogram. The measure of angle C is 40 degrees.